So in this video, we're going to talk about how to write an equation of ellipse given specific characteristics. So remember, we've got the equation of ellipse right here. However, I do want to remind you that your a squared and b squared can be reversed, okay? You do need to remember that a is always greater than b. And the relationship between a, b, and c is defined as c squared is equal to a squared minus b squared, okay? So using that information, we're going to write some equations. We're going to drop down to problem number 1, and let's see what we got here. We have a center, so this is going to be our HK. We know that our focus is at 6, 4. The semi-minor axis length is 4, so semi-minor is b, so we know b is equal to 4. And basically, I want to try to figure out how this graph looks so I know, is my semi-major axis horizontal? Is my minor axis vertical? Like, what does this thing look like? So take a second and draw just a quick sketch. So I know my center is at 3, 4. And I know my focus is at 6, 4. So that means there's another focal point somewhere over here, which means my ellipse is more elongated horizontally than it is vertically, okay? So that's going to tell me that my A value is going to be under the x-axis, the x part of the graph, yeah, not the x-axis, and that my b value is going to be under the y part of the graph. All right, so let's go ahead and find the a value because we don't know that. All right, so c squared is equal to a squared minus b squared. So let's see what we've got here. The distance from the center to one of your foci, all right, one of your focal points is going to be, in this case, 3. So that's going to tell me my C value. I was given the semi-minor length, so I know C and I know B. Let's find A. So this is going to be 9 is equal to a squared minus 16. I'm going to go ahead and add 16, and I'm going to know that a squared is equal to 25. Now, could I take the square root of that and figure out what A is? Absolutely. Am I going to take the square root and figure out what A is? Absolutely not. All right. The reason being is I need to write the equation, and the equation has A squared in it, not A. Is it going to be a pain if you do it? No, you can absolutely figure out what A is. You just don't need to. Okay. All right, so let's put it all together. We've got x minus 3 squared over plus y minus 4 squared over is always equal to 1. And the part that I want to figure out here, all right, so my major axis is horizontal, which means this a value, this a squared value, is going to go underneath my x part of the graph. And then I'm going to take b and square it to figure out what goes underneath y. So 4 squared, 16 there. All right. So that is the standard form of the graph. This particular worksheet is numbered a little weird, so I'm going to go down to get to problem number 2. Okay. Right, the equation of ellipse satisfies the following information. All right, we've got 2 foci. We have a semi-major axis length. So A is equal to 6, okay? And if we know the 2 foci, let's do a quick graph here. So positive 3, 2, so that's 3, 2. Positive 3, negative 2. So those are my 2 foci, which tells me that this graph is elongated vertically. And it also, I know that my center has to be right between the 2 foci. So my center is going to be at 3, 0. So now I know my center. I know my A value from the center to either of the 2 focal points is going to give me a C value of 2. So let's see, C squared is equal to A squared minus B squared. So 4 is equal to 36 minus b squared. So if I move a few things around here, I'm going to move the b squared to the left and then subtract 4. I'm going to get b squared is equal to 32. All right, so putting this together, let's see, we've got x minus 3 squared plus y squared is equal to 1. Now we've got to fill in those denominators. So we are more elongated vertically, right? My major axis is vertical here. So the a squared value is going to go under y. So that's going to be 36. And my b value, my b squared value is going to go underneath x. So 32. And that is my handy dandy equation there. All right. All right, let's go ahead and slide on down to number 3. Write the equation of the ellipse that satisfies the following information, and I'm giving you the vertices this time. So definitely take a moment and graph this out for yourself. So let's see, 1, and I'm going up to positive 8. And then I have 1, 0. So let's see, 1, 8, 1, 0. Negative 1, 4. And 3, 4. All right, it's not perfect. And my picture definitely did not make it look any better, but it gives me the idea of where things are. So if I go ahead and look at this vertical axis here, that was 8 units tall. So that's going to be half of it would be 4. If I look at this horizontal axis, I am going from -1 to +3, which is a total of 4 units. So if I chop that in half, it's 2, which means this is more elongated vertically than it is horizontally. It's kind of hard to see it on the picture, but you can kind of get the idea. All right, so we've got a center here of, let's see, that would be 1, 4. And we've already counted out the image, so we could just use those values. We actually don't need to know where the 2 foci are. So x minus 1 is squared plus y minus 4 squared is equal to 1. All right, denominators here. Along the horizontal axis here, that's going to be 2 and square it, so that's going to be 4 here. Vertical axis, we're going to look at that 4, square it, and that's your 16. So there is your standard form. All right, I'm going to go ahead and slide over to, I don't know, number 6 here, I guess, which is actually the same kind of problem. Let's see if I can make this picture look any better than the last one. All right, so let's see. 3, 4 is right here. -3, 4 is right here. 0, 5, and 0. Wow, that's really high. So let me try that again. 0, 5, and 0, 3. All right, so slightly better this time at the graph. All right, so my center is going to be, let's see, 0, 4. And if we count this out, so that would be 3 units horizontally from the center and 1 unit vertically from the center. So let's see, x squared. And if we look at the x-axis, or these the horizontal axis here, we're going to take 3 and square it. So that's going to be 9 plus y minus 4 squared. Let me try that again. Get that the right place. Okay. Y minus 4 squared. Okay, there we go. And then along the y-axis, we've got this vertical axis here is 1. So if we square that, it's going to be 1 is equal to 1. Now I am going to do one quick thing here. This is what's called standard form. And I'm going to take a minute and I'm actually going to translate this into general form. You haven't really seen that yet. It's not terribly difficult to do. It just depends on how large your denominators are. What I'm going to do here is I'm actually going to multiply everything by the LCD, which in this case is 9. So if I take 9 times x squared over 9 plus 9 times y minus 4 squared over 1, and I'm going to take 9 times 1. All right, so 9 over 9 will cancel out, just leaving x squared, plus this denominator of 1 I don't have to worry about. Dividing by 1 doesn't do anything. So I'm just going to multiply out y minus 4 squared. So y squared minus 8y plus 16. 9 times 1 is 9. So x squared plus 9y squared minus 72y plus 9 times 16 is not going to happen in my head. So let's grab a calculator. 144 equals 9. So x squared plus 9y squared minus 72y plus 144 minus 9 would be 135 is equal to 0. So this is general form, right? And what we had originally written in was standard form. Now, these directions just said to write the equation. If there is nothing specified in the problem, I 100% write the answer in standard form. I just want you to see how you can translate to general form, and if you have more questions about that, let me know. But basically just multiply through by your LCD so you can get rid of the fractions. All right, I'm going to go ahead and go backwards up the list here. Problem number 5, we've got a center, a focus, and a semi-major axis length. So semi-major axis length is going to be our A value. So A is equal to 8. Let's see. If I go ahead and graph this just quickly. So 3, 0, and negative 4, 0. So that's going to be a really elongated horizontally. Let's see. Our C value here is going to be 7, right? To get from 3 to negative 4 is 7. So C squared is equal to A squared minus B squared. So 49 is equal to 64 minus B squared, which means B squared is equal to 15. Again, you don't have to simplify that or do any kind of rationalization at all with that to reduce the radical at all. What you do have to do is write the equation. So let me grab that center. So let's see, x minus 3 squared over. Now, on the horizontal axis here, that's going to be your major axis. That's going to be the 8 value squared, so 64. Okay, plus y squared over, and then our b squared value is going to go there because that's the minor axis, equal to 1. And problem number 5 is done. All right, last problem is problem number 4 here. Let's see what kind of information we were given. 2 foci and a semi-minor axis length of 4. So B is equal to 4 here. And if we've got our 2 foci, we can find the center. So let's see here. Let's go ahead and graph this up. 6, 1, and 2, 1. Makes my graph look something like that. Center is going to be right between them. So the center is going to be 4, 1. If that gives me a C value of 2, right? To get from 4 to 6 is 2 units, or to get from 4 to 2 is 2 units. So let's see. C squared is equal to A squared minus B squared. So 4 is equal to A squared minus 16. So go ahead and add 16 to both sides. A squared is 20. All right. So we've got x minus 4 squared over, this is going to be the A value because that's the major axis horizontally, plus y minus 1 squared over, your B squared value would be 16 is equal to 1. All right. That takes care of ellipses day 2. If you have any questions or concerns about where any of these equations came from, why I did what I did, please send me any messages or concerns in either Canvas or an email.